And so this story is described in a very interesting book called Bad Pharma by Ben Goldacre, who's also written a paper called, a book called Bad Science, which is very entertaining if you want to feel bad about science. Here's another paper. This is from British Medical Journal, which is about they studied meta-analysis. So they studied these cancer medications that were approved by the European Medical Agency, European Medicines Agency, and so they looked at so these approved cancer drugs and how they fared the follow-up, so how well they were. And of those, all of these that they studied, half showed really no demonstrable benefits on survival or quality of life. And we're going to move on to some reasons for what's behind this, and one of these that we need to discuss is the issue of p-values. So this guy here is Sir Ronald Fisher, who is a very famous statistician for actually inventing the p-value, if you have heard of that term. Basically, everything in social science, also in medicine, relies on publishing some effect and doing a statistical test, and the test result is summarized in a statistical number, which is then, and the p-value then is about it's a description of how rare the effect would be, but we will discuss this at length soon. So this guy, Ronald Fisher, he liked smoking pipes, and he also liked doing agricultural experiments. And fun fact, by the way, that he was also a very great advocate of the tobacco industry, and for a very long time he was arguing against these people who were saying that smoking is bad for you, and he was saying it's mostly a genetic issue, and there's no way smoking can actually be bad for you. But with agricultural experiments, you needed random allocation to make the p-value work. This is, of course, it's not something we have. Many times we're looking at correlation or observational settings in the social sciences, and that's okay as long as we know what we're doing. But the robust application of the p-value required randomization, and it's not clear whether or not p-value should be calculated in the absence of randomization. What it is when you don't have a randomized setting. But anyway, this p-value, it's often taken, it's also called the alpha threshold. There's the usual threshold is 0.05, which was an arbitrary decision. It was, as Fisher put it, he said that you need to always decide on what's the appropriate threshold for you. So, but what we now see is that everyone uses 0.05. And there's been a lot of talk about transforming this or lowering it or getting rid of it altogether, but what you basically need to just know is that there's nothing magical about 4.0. And here's a famous paper when they looked at the psychological studies. They looked at these things called researcher degrees of freedom, which also can be termed questionable research practices. But basically, the point is that if you can pick and choose different ways to do your analysis and pick the research, the subgroups and so forth. If you can do that ad infinitum, you can always get a so-called statistically significant effect. So you can get a p-value under 0.05. And yeah, we're going to look at this next. If you want, you can download this spreadsheet from this website.